All right, we're continuing on page 2 of the closure problems for chapter 2. Here we go. It says, use what you know about transforming parent graphs to write an equation for each of the graphs described below. And we're going to start with question A. A parabola stretched by a factor of 0.25, opening downward, shifted 12 units down, and 3 units left. All right, so let's take apart each of these descriptions. If it's a parabola, it needs to be y equals x squared. If it has a stretch factor of 0.25, that's the a value. So a is going to be 0.25. If it's opening downward, then we know that the a value has to be negative, less than 0. If it's shifted 12 units down, we know that the k is going to be negative 12. That's a vertical shift. And if it moves 3 units to the left, that means that the horizontal shift of h is negative 3. So I'm just going to take all that information and put it together, and I'm going to call it y equals negative 0.25, right? It's negative because I'm applying this and this at the same time. Negative 0.25 x minus, I'm subtracting negative 3, so it's plus 3 squared minus 12. All right. And I'm just kind of double checking my answer as I look at this. Opening downward, shifted 12 units down, 3 units to the left. All right, great. So let's go to the next one. I'm going to clear some space here. All right, let's look at a cubic with a stretch factor of 2, locator point at negative 6, 1. So if it's a cubic, it's y equals x cubed. The stretch factor is going to be 2. H is negative 6. K is 1. So we're going to write it out. Y equals 2 times x minus, I'm subtracting negative 6. So it's plus, and it's not squared, it's cubed, excuse me, there we go. And then plus 1. Stretch factor of 2, locator point at negative 6, 1, and it's cubic. All right, question C, an inverse function with a locator point at 2, negative 6. Okay, so it's inverse. That's y equals 1 over x. And then h is 2, k is negative 6. So we're going to do y equals 1 over x minus 2 minus 6 on the outside. I don't know what the stretch factor is, so I just left it as a 1. That's a guess, which is fine. All right, now we're getting into some graphing. Here we go. I'll just move some of this stuff over, or even down to the bottom might be better. All right, we're taking a look at this equation, and we're being asked to do these 4 things with it: x-intercept, y-intercept, vertex, and the graphing form of the equation. Okay, so let's start with x-intercepts. If you want to find the x-intercepts and you have the equation in standard form, which is what this is, you need to factor. And if it's not factorable, you would have to use the quadratic formula. But let's take a look and see if it's factorable first. Okay, so here we go. When we factor, we make a box and we set up a diamond problem. We take the first term and we put it in the lower corner. We take the last term and we put it here. And then when we set up our little diamond problem on the side, we multiply these 2 things together. So it becomes 12x squared. Then we take the middle term and we put it on the bottom, 8x. And then I'm looking for 2 numbers that multiply to 12x squared and add to 8x. So that looks like 6x and 2x. And if you need practice on that, you want to think about 12x squared and all of its possible factors. So like 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and then 12 and 1. And of course, these would all have x's in them. So these are combinations of terms that multiply to 12x squared. Now, they could also all be negative because these combinations would also all multiply to 12x squared. So you have to be clever about it. But then you're going to look at the list and ask, do any of these also add to 8x? And so the combination that adds to 8x is right here, right? These 2 numbers multiply to 12x squared, but then 2x plus 6x is 8x. So that's how I got what I got inside the diamond problem. Okay, I'm going to clear some space here. All right, so next, I'm going to take the green numbers, which are the solutions to the diamond problem, and I'm going to put them here, 6x and 2x. Okay, I'm going to put them inside. And then I'm going to label the lengths of the sides. So this piece here must be an x by x piece. Okay, this piece here, since it has an area of 2x and the left side is 2, this must have a length of 2. This must have a length of 6. And then I want to check, is 6 times 2 equal to 12? It is, so that all works out. So this equation, what this all means, right, is that if I factor this, this is equal to x plus 2 times x plus 6, which is like this side and this side multiplied together, okay? So the result is that I got x plus 2 times x plus 6, that is the same as x squared plus 8x plus 12. And if you're not sure, you can use distributive property, right? X times 6, 2 times x, and 2 times 6, and then add them all up, and you should get this. Now that I have rewritten the equation as a product, I'm going to take my product, and I'm going to use it to my advantage. So x-intercepts, I'm going to go kind of like back up here at the top. X-intercepts are where y is equal to 0. Because if I think about the graph of whatever parabola this is going to be, like let's say the parabola is going to look like this, okay? The x-intercepts are here and here. And since they're on the x-axis, y is equal to 0 at like both spots. So I want to ask the equation, please tell me where y is 0. Like what are the x values that make y equal to 0? So I'm going to just set this thing equal to 0 on the bottom, right? I'm saying that y is now equal to 0, okay? All right, now we move into the next piece of logic, which is that if this times this, if these things multiply together to make 0, then either the first term is equal to 0 or the second term is equal to 0 or both, right? So this is called zero product property. So zero product property says that if two things, thing 1 and thing 2, are multiplying together to equal 0, then either the first thing is equal to 0 or the second thing is equal to 0 or both of them are equal to 0, because that's the only way that things can multiply to 0. So then I can say, oh, okay, well then this means that either x plus 2 is equal to 0 or x plus 6 is equal to 0 because of the zero product property. So this would mean that x would be equal to -2, and this would mean that x is equal to -6. And so those are my two x-intercepts. Those are values of x that would make y equal to 0. So I've found the first blank, and admittedly that was a ton of work to find the x-intercepts, okay? So this means that when x is -2, y is 0, and when x is -6, y is 0. And so immediately that tells me actually that this particular drawing was a complete guess, that it's not quite right because my x-intercepts are not lining up with that. So I'm going to go ahead and just like erase this, okay? So down here I can start to put those in place, -2 and -6 as my x-intercepts. So 1, 2, 3, 4, 5, 6. So one at -2, one at -6. All right. Let's take a look at the y-intercept, okay? So the y-intercept is where x is equal to 0. So this is going to be a place, struggling with my pens here, where x is equal to 0. So I'm going to go back to my equation, which was this, y equals x squared plus 8x plus 12. It's the original equation. And I'm basically going to ask where or what is y when x is 0? So where is x equal to 0? Okay? So I'm just going to go ahead and plug in zeros for my x's. Okay? 0 squared is 0. 8 times 0 is 0. So y will be equal to, 12 when x is equal to 0. That's my y-intercept. So when x is 0, y is 12. Okay, so to get your x-intercepts, you plug in 0 for y. To get your y-intercepts, you plug in 0 for x. Okay, my parabola is forming nicely here. So now I'm going to go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So way up here. And I'm going to put a dot at 0, 12. That's my y-intercept. Okay, next, let's go to the vertex. All right, the vertex. Okay, I have two options for finding the vertex. Option one is that it's pretty safe to say that the vertex is going to go right down the center of the two x-intercepts, because it looks as though my parabola is going to be something kind of like this to get through all these points. So the vertex is going to be like somewhere kind of down here. I don't know exactly where. So if this is a -6 and this is a -2, then the vertex will be halfway between them. So this will be at -4, comma something. That's a question mark right there. I don't know what the y-coordinate is, but I'm positive that the x-coordinate is -4 because it has to split the difference. It has to be the average of the x-intercepts. Okay, so this comes from averaging average of the x-intercepts. Okay, average of the x-intercepts. All right, then if I know that the x-coordinate is -4, then I can just plug it back into the equation. So I'm going to go back to y equals x squared plus 8x plus 12. And I'm going to find out y when x is equal to 4. So I'm going to let x equal -4 and then figure it out. So here we go. Y equals -4 squared plus 8 times -4 plus 12, right? So that's a 16. That's 32. That's 12. So this is -16 plus 12. This is -4. So when x is equal to -4, y is equal to -4, and this will correspond to the point -4, comma -4 as my vertex. So vertex is at -4, -4. And I'm going to go ahead and label that right here, this spot, and I went too far. This is -4, -4. All right, I have all of my points, and now I'm just going to work backwards. The graphing form of the equation is always y equals a times x minus h squared plus k. And this thing here is telling me that h is equal to -4 and k is equal to -4. So I'm going to write this with my h and k. So y equals x minus -4 is plus 4 squared, and then -4 for my k. And that is how to get the first parabola. I'll do the second parabola in my next video.